And so for number 5, we have this function, 2x minus 16, 2x squared minus 16x plus 30. And as I've done in the past, I went ahead and graphed this on GeoGebra so we could just kind of see what was going on. And our first question is, does the function have a maximum or minimum value? And so a couple things to know. Number one, our leading term is positive, and so this function is going to open upwards like a smiley face. And so it's going to have a minimum because it's got a definitive bottom to it. And if you kept following this thing up, you could follow it up forever. It would just keep going. But right there, it does not go any lower than -2. And so we will see that our minimum point is going to be the value or the coordinate for -2. We'll get to that in a little bit. But the other piece is figuring out it's asking us where does the maximum or minimum value occur? What is the maximum or minimum value, and does it have a maximum or minimum? So again, we know that it's going to end up being for -2, but we've got to figure out mathematically how to determine that. And now the thing to remember from either the notes or a previous thing is this minimum value right here happens at the vertex. And so when I do -b over 2a, I should get an x value of 4 that I can put back in that will produce a y value of -2. Let's see what happens with that. So just to get us going, does the function have a maximum or minimum? Again, since its leading term is positive, it is opening upwards like this, which means that it does have a minimum value down there at the bottom. So this function will have a minimum value. There is no maximum, it just keeps going up forever. So what is the function's maximum or minimum value? Well, the way to determine that is to find the vertex. So we use -b over 2a. -b, we have -16. 2a, we have our a value is 2. So we get a positive 16 over a positive 4. 16 divided by 4 is 4. We need to remember that that is our x value. And we can see that on the graph that I am using as an example that our minimum value or our vertex does occur when x is equal to 4. It's going to land at the point for -2. And we'll see that in just a moment. So this question is an interesting one. What is the function's minimum or maximum value? The answer is not 4. The answer that this happens at the x value 4. For us to figure out what the minimum value is, they're actually asking for the y value. And so to find the y value, we've got to go ahead and I'm just going to replace that g of x with y because those things are interchangeable. And y is a little bit easier for me to work with. For us to figure out what the y value is at the minimum, we need to put that x value in there. And so we will have y is equal to 2 times 16 minus 24 plus 30. And just checking my math really quick. Okay. We have y equals 32 minus 24 plus 30. So 32 minus 24 is going to give us 8. Sorry, negative. Something is goofy. Let me pause for a second and find my mistake. So it looks like I made a typo. I wrote 6 instead of 16. So that number that was -24 is going to be -64. I hate typos. I've been making a lot of them in this homework assignment, it seems like. So 32 minus 64 is going to give us -32 plus 30. Y equals -2. So when they ask what is the function's minimum or maximum value, the minimum value is -2. Notice I am not doing the ordered pair for -2. It's just -2 because that's as low as the function goes. It happens at the x coordinate 4, but that has nothing to do with the actual minimum value. Which brings us to the next question. Where does the minimum or maximum occur? The minimum occurs at x equals 4. And so again, for this, it's not asking for an ordered pair. It's just asking for a specific x value or y value. First, what is the minimum? And then where does it occur? All right, that's it for number 5.